All right, everyone, grab a seat. Welcome to the freshman class of Clean Energy Chemistry 101. I am absolutely thrilled to be your professor for today's explainer because we're tackling one of the most fascinating and honestly vital pieces of technology in the modern scientific landscape, fuel cells. If you've ever wondered how we're going to power the future without constantly plugging into a wall or, burning fossil fuels, you are in the exact right place. So let's just dive right in. Here is our syllabus for today. We'll kick things off with a welcome to Clean Energy 101, then map out the anatomy of a fuel cell. After that, we'll take a step-by-step energy tour, pit fuel cells versus batteries, look at the high-efficiency advantage, and wrap it all up with some exam prep and key takeaways. Okay, Module 1. Welcome to Clean Energy 101 and the basics of galvanic cells. We gotta lay down a solid foundation before we start building up the complex chemistry. So, at its absolute core, a fuel cell is a type of galvanic cell. But what does that actually mean in plain English? Well, it takes chemical energy in an oxidant system and directly converts it into electrical energy. And the key word there is directly. There's not burning, no spinning turbines, no middleman whatsoever. It pulls this off through a really elegant electrochemical process. Basically, it's just chemistry doing all the heavy lifting, instantly giving us the electricity we need. Now that we know what it is, let's open up the blueprint. Module 2. The anatomy of a fuel cell. How is this physical system actually put together? Honestly, think of it like a highly specialized sandwich. On the outside edges, you've got your fuel on one side and your oxidizer on the other. Moving inwards, you have two electrodes. Those are your slices of bread. And right in the middle, sandwiched perfectly between those electrodes, is the electrolyte. Every single electrochemical cell shares this basic structure of two electrodes and an electrolyte. But it's how the fuel and oxidizer interact with this exact setup that really makes the magic happen. Which brings us to Module 3, our step-by-step energy tour down the electrochemical highway. Think of this whole process as a microscopic, high-speed highway. Step 1. At the first electrode, which we call the anode, the fuel undergoes oxidation. And when this happens, it liberates electrons. These electrons are suddenly free and just absolutely packed with energy. Step 2. Those liberated electrons can't actually travel through that electrolyte sandwich filling we talked about. Instead, they're forced to take a detour through an external circuit. And this detour, that's our highway. As they travel this external circuit, they perform useful work. This is the exact electricity currently being used by the aerospace industry to power satellites, by the auto sector for zero-emission transit buses, and by major tech companies for silent, reliable data center backup power. Finally, step 3. The electrons arrive at the second electrode, the cathode. Here, the oxidant gets reduced, combining with the electrons to form reduced products. It's just a beautiful, continuous, flowing journey. All right, class, let's pivot to Module 4, fuel cells versus batteries, or as I like to call it, the factory versus the storage unit. We really need to compare this advanced tech with something you literally have in your pockets right now, the conventional battery. Let's consult the course materials and break down the fundamental differences here, because this is where the sheer genius of the fuel cell really, really shines. It all boils down to a super simple analogy. A fuel cell is exactly like a factory. It produces electrical energy continuously, nonstop, for as long as you keep feeding raw materials, the fuel and the oxidants, into the system from the outside. Because it's a factory, it doesn't actually store the chemical energy. It just processes it, which means it never requires recharging. No dead batteries here. Now contrast that with a conventional battery. A battery is just a storage unit. Its reactants are an integral, built-in part of its construction, meaning it physically stores chemical energy inside itself. Because of this, it can only produce power until the materials trapped inside the cell are completely depleted. Once that storage unit is empty, it dies, and you're stuck looking for a wall outlet because it has to be recharged. So, a continuous factory versus a depletable storage unit. Let's move to Module 5. The high-efficiency advantage, and why this matters so much. That continuous design gives the fuel cell a massive operational advantage. Fuel cells operate with an incredibly high efficiency of production for electrical energy. Conventional batteries, they're stuck operating at a pretty low efficiency. But honestly, it goes way beyond just power. Because fuel cells are constantly fed from the outside, they need far less attention and babysitting compared to batteries, which require constant monitoring and maintenance. And perhaps most importantly for us today, the waste produced by a fuel cell is entirely harmless, whereas the chemical waste products from conventional batteries can be highly toxic and harmful to our surroundings. Actually, there's a definitive quote straight from our materials that sums this up perfectly. They are eco-friendly as the products of the overall reactions are not toxic and hence no environmental problems. That's incredible, right? We get high-efficiency power, and the only byproduct is completely harmless. Add to that the fact that fuel cells operate silently, no roaring engines, no clanking mechanical parts, and you're looking at a technology that is radically different from traditional power generation. All right, we are nearing the end of today's lecture. It's time for Module 6, Exam Prep. Pencils ready, please? If you want to absolutely ace the final exam, these are the definitive advantages you must commit to memory. First, they produce continuous energy as long as fuel is supplied. Second, their power efficiency is incredibly high. Third, they are eco-friendly with entirely harmless waste products. Fourth, their operations are completely silent. And finally, there is absolutely no need for charging. They are power factories, not temporary storage units. Which brings us to the end of our explainer today. But I want to leave you, my brilliant freshman class, with one final thought to chew on. If fuel cells can truly offer continuous, highly efficient energy without ever needing to be plugged in and recharged, how is this chemistry going to entirely rewrite our future? Think about it. Class dismissed, and keep exploring.